this is Mrs. Henfarth. I'm doing lesson 11, graphing from factored form. For this lesson, you're going to need your notebook or some graph paper, maybe some colored pencils or a highlighter. Our learning objective today is to graph a quadratic function in factored form. We're also going to find the vertex and the y-intercept of the graph of a quadratic function in factored form, and we're not going to be graphing it first, so we're going to be able to look at the equation and figure it out. So let's just review from last week. So what I've got, and if you want to jot this down, draw this quick graph, you'll notice that I've got a parabola, and I've got the parabola labeled with some ordered pairs A, B, C, D, and E, F. And I'm giving you the function, defining the function as w of x is equal to x plus 1 times x minus 3, and I'm writing it in standard form as x squared minus 2x minus 3. So what I'd like you to do is find the values of A, B, C, D, E, and F, and be prepared to be able to explain your reasoning, how you came up with those values. Hopefully you remembered from last week that B and D must be 0 because they are the y-coordinate of the x-intercepts of the graph of any function is always 0. So anytime I'm on the x-axis, my y value is going to be 0. Subsequently, I can say the same thing about my y-intercept, that if I'm on the y line and I'm looking at the intercept, my x value is always 0. Therefore, E is 0. Trying to figure out the rest of the numbers, you'll notice that I've got -1 for A. I have C is 3, and I've got F is 3. So I'm hoping, again, you remembered from last week. I'll look at the y-intercept first, F, that in standard form, my y-intercept is the last term in the standard form. I also note that if I know that x is 0, I could go up and insert 0 and 0 for the values of x, and I get 1 times, this is -3, not +3. 1 times -3 is -3, which verifies here and verifies there on my graph. Also, if you remember again from last week, that if I looked at the factors, you may have remembered that when I have a factor in an expression, that I'm always going to be taking the opposite of the sign that's in the factor. So again, if I've got +1, I know that A has got to be -1, and C, because x says -3, then I knew that that would be +3. So again, just building on last week's lesson, what we are going to be doing in this lesson is we're going to continue to make sense of the earlier work that we did, and we are going to be looking at the factored form of a quadratic expression as well as the x-intercepts of its graph. Again, I want to remind you that x plus 1 and x minus 3 are the factors, and this is the factored form of the quadratic expression. So we're going to be looking at a function, and what I'd like you to do is jot down this function, f of x is equal to x plus 4. And you'll notice that what I've done is we've got a table of values here, a t-table, and we are going to fill in and complete the values for this function. From the table, we are then going to determine the x-intercepts and the vertex, and then from there we'll graph it. So what I'd like you to do is notice that I've got my t-table values from -5 for x all the way down to 5, and I've already given you some f of x values. The other thing I want to remind you is that x is the input and f of x is the output. So I'll go ahead and I'll do an example when x is equal to +3, how to substitute that 3 back into the equation, and then you're going to do the rest of the numbers. So if I know that x is 3, what I'm going to do is I'm going to substitute and go f of 3 is equal to 3 times 3 plus 4. Simplifying, I've got 7 times 3 is 21. Therefore, my input when x is 3, my output is y, or f of x, is equal to 21. So I'd like you to go in and I'd like you to do the rest of the table. I went in and populated the rest of the table, and I just need to make sure that you check your values against mine. So now what we're going to be doing is we're going to be looking at our table, and we are going to figure out from looking at the table what are the x-intercepts. In addition to the x-intercepts, we're also going to be looking for the vertex, building on what we learned last week. So I want you to just take a look at the table and see if you can figure out what the x-intercepts and the vertex are. Well, looking at the x-intercepts, if I remember from my previous graph here, I'm noticing that my x-intercepts, my y value is always 0. So when I look here, I'm looking for when my y value is 0. And right here, I've got an output or y value of 0. And I also right here have a y value of 0, or my output. So therefore, my two x-intercepts are -4, 0 and 0, 0. So now what I want to do is I want to look for the vertex. And one thing I want to remind you about the vertex is the vertex on a parabola is where the function changes direction. So from here to here, I have a decreasing function, and on this side of the vertex, I have an increasing function. And in this particular case, if my vertex is down at the bottom, this is where it changes direction. So it goes from a decreasing to an increasing. So when you look at the table of values, you're looking at where do you see my function going from a decreasing to an increasing. Take a moment, take a look at those and see if you can figure it out. So in looking again at my graph, I want to remind you that as I come down, I've got a value, and as I come back around and come back up, I want you to notice that both of my y values are the same. So therefore, if I look at my table, I notice that I've got the y value and the y value right here as the same. Therefore, my vertex is right here. And I know it's my vertex because I'm going from -3, -3 to -2, 4. Then I'm going up to -1, -3. So I'm changing direction right here at this -2, -4. So my vertex is -2, -4. So what we're going to be doing is taking these values, my table, and inputting them into a graph. And what I've done is I've started a graph right here, and you're going to notice that my x-axis is labeled in increments of 1, and my y-axis is labeled in increments of 10. And what we're going to do is we are going to go ahead and graph f of x is equal to x times the quantity of x, I believe it was x plus 4. And you've got the table of values that you can use on the previous page or from your table. So go ahead and do that right now. So as you can see, I did red dots and yellow dots, and I want to explain why I did them in two different colors. So you'll notice that it doesn't, so I go from -5, -5, 5, -4, -0, -3, -3, -2, -4, -1, -3, 0, 0, and 1 comma 5. Well, I noticed that these values here all seem to be the same on the other side. In other words, I noticed just from my graph that they were mirrors. And at the bottom is my vertex right there. And I noticed that I didn't have, that's why I did these in yellow, it's because I noticed that I had nothing that was pairing on this side, which I thought was kind of interesting. And then I wondered, like, if I would have put things in like -6, if maybe it would have mirrored on the other side. Again, that's just something to think about. So from my graph, if I connect my dots, my points, you're going to notice that I've got a parabola. And I'm also going to notice that I've got my x-intercepts right here and right here. And I'm going to notice that, yes, indeed, there's the vertex. But I also want to pay attention to my x and x plus 4. Those seem to have some kind of relationship. And if I go back to my table, I remembered something about the output of 0 and the output of 0. So that means if I were to plug in -4 into this equation right here, if I were to take -4 and add 4, I'd get 0. And 0 times 0 gives me an output of 0. And subsequently, if I use 0 for my input right here for x, well, and if I put in any number here, any number times 0 is 0. So that's just something to notice. Then my vertex, -2 comma 4. But when I look at this graph, I'm noticing that it seems to be equidistant. So what I did was I decided I would blow this up a little bit more. And I'd say, okay, if that's -4 comma 0 and that's 0 comma 0, the halfway distance between -4 and 0 is -2. And like, well, wait a minute. That -2 was the x-coordinate of my vertex. So then the only thing I needed to worry about was how would I find the y value? Something to think about. So as we continue through this lesson, and we looked at the graph, and we saw that the graph gives me my x-intercepts, I also noticed that I get the vertex as well. So I'm wondering what do I need in order to be able to sketch a graph, and can I get additional information from the factored form of a quadratic? Well, let's take a look at a few more examples. So if I have f of x, so jot this down, f of x is equal to x plus 3 times x minus 5. And what we need to know is, can I figure out what the x-intercepts are without graphing? And can I get the x-coordinate of the vertex? Well, if I can visualize the graph, I know that the factors have something to do with that. And I know that if I have factors and that the output needs to be 0, therefore the output being 0, that means my y, what value of x, when I add it to 3, gives me 0? Well, -3 does. So -3, and I know my y-intercept always has to be, or my x-intercept, when I have an x-intercept, my y value is always 0. And I therefore notice that it seems to be the opposite of that value right there. So instead of +3, I've got -3. Okay, so therefore my second intercept could be 5, 0. And I can verify that by if I take and I go x minus 5 is equal to 0, well, what number do I subtract from 5 that gives me 0? Well, 5. Perfect. So now I'm going to try to find the x-coordinate of my vertex. So if I think about what we did previously on this graph right here, I took the halfway point between these two values. So if I'm at -3 and I'm at 5, what's a number that's right in between both of them? Well, 1 is. So my x-coordinate is 1. So x is equal to 1 for my vertex. Okay, let's look at another example. So if I give you that g of x is equal to 2x times the quantity of x minus 3, I want to do the same thing. I want to find out what are the x-intercepts, and I want to find the x-coordinate of my vertex. Okay, so again, thinking about the output needs to be 0, and my output needs to be 0. Therefore, what do I multiply 2 by to get to 0? 0. So my x-intercepts are 0, 0. And what's the second intercept? Well, what do I add to -3 to get to 0? I add 3. So 3, 0. And again, I didn't have to graph it. I was able to look at the two factors. So now what I need to do is find the coordinate of the vertex. So if I have 0 as one of my x's and 3 as the other, so what's a number that falls right in the middle, which would be equidistant between the two? Well, it would be 1.5. So I'm hoping that you're beginning to see the pattern. I can continue and do another one. We have h of x is equal to x plus 4 times 4 minus x. What I'd like you to do is I want you to find the x-intercepts, and I want you to find the x-coordinate of the vertex. As you can see, I found the x-intercepts as -4, 0 and 4, 0. And my x-coordinate of the vertex was 0. We're now going to layer on a little bit more, and this time we're going to look at being able to figure out what is the x and y coordinate of the vertex. So let's take a look at this. We've got x minus 7, or I'm going to say y is equal to x minus 7 times x plus 11. Okay, what I want you to do is, taking a look at the two factors, we know that the x-intercepts are going to be 7, 0 and -11, 0. Well, if I know that, and I want to figure out the x-coordinate of the vertex, what I'm going to do is find the point that sits right in the middle between 7 and -11. And that value is x is equal to -2. If I know the value of x is equal to -2, and I know that my vertex has got x, y, and I know that this is -2, I can figure out what my y is by plugging the x back in to my equation and solving for y. Let's go ahead and do that. Y is equal to -2 minus 7 times -2 plus 11, which is equal to -9 times 9. Therefore, y is equal to negative 81. I now have my ordered pair of my vertex of negative 2, comma, negative 81. Okay, so we're ready to go ahead and do our exit ticket. So here is the exit ticket. If I give you that f of x is equal to x minus 2 times the quantity of x plus 4, what are the x-intercepts? What are the x and y coordinates of the vertex? What is the y-intercept? And can you sketch a graph? A quick sketch of a graph given or using the x-intercepts and the vertex and the y-intercept. So I want you to go ahead and work on those 4 questions, and then on the next slide, I'll show you how to do them. So, question number 1, what are the x-intercepts? As you can tell, I'm going to use my factors. And so basically I know that I have 2 ordered pairs. I know that my y value is 0. And then I'm looking for the value of x that my output will be 0. So I know it's going to be 2. Oops, not negative 2, 2. It's going to be 2. And I can also remember that I always take the opposite sign of what's inside. And then for the second intercept, it will be negative 4. For the next question, it asks me what are the x and y coordinates of the vertex. And again, remember, I want you to remember that I'm taking, in order for me to find the x value, I'm taking the halfway distance or the point halfway between 2 and negative 4. Therefore, I know that x is going to be equal to negative 1. And I can find the y value by substituting the value of x is equal to negative 1 back into my factors right up here, which means it would be negative 1 minus 2 times the quantity of negative 1 plus 4. Go ahead and simplify. Negative 3 times 3, which is 9. Oh my goodness. Therefore, my x and y coordinates are x is equal to negative 1 and y is equal to negative 9. Okay, so that's for my vertex. And then for my, what is my y-intercept? Well, I'm going to remember that when I'm on the y line, my x is always 0. Therefore, I can substitute 0 back into my expressions right here. Put 0 in both times, which means I've got 0 minus 2 times 0 plus 4. Therefore, I have negative 2 times 4, which is equal to negative 8. Therefore, I know that my x is 0 and my y value is negative 8. Now, the only thing I have to do is sketch a graph.